Okay, video 2, we are going to talk about the actual function of f of x equals the square root of x. But before we do that, let's get a few things defined. So this, what I'm highlighting right here, is called the radical symbol. Inside the radical symbol, we have what's called the radicand. So the expression inside the radical symbol is called the radicand, and then sometimes we have a number in this little spot right here. That number is called the index. When there's not a number there, we're talking about the square root. That's the most common root, is the square root. But sometimes we may be talking about a cubed root or a fourth root or a fifth root. So let's graph f of x equals the square root of x. And I'm going to do this by creating a table. So rather than call it y, because we're calling it f of x, I'm going to make the table x and then f of x. And we know that f of x is the same thing as the square root of x. Now, if I put a negative number as the radicand, the square root of a negative number is not real. That is not real. Because there's no real number times itself that's going to equal a negative. So for instance, if I have the square root of 25, we know that that's 5 because 5 times 5 is 25. But if I have the square root of negative 25, there's nothing times itself. There's no real number times itself that equals negative 25. Negative 5 times negative 5 is still positive 25. So there isn't a number that you can multiply by itself that's going to equal a negative until you start getting into imaginary type numbers. And we're talking about the real world, the real number system. So we're gonna stick with our real numbers. And our real numbers go from negative infinity on the left to positive infinity on the right. So now that we know that we can't put any negative numbers, none of these negative numbers can go in for x. Let's start with 0. When we put a 0 in for x, so I put a 0 into the radicand, right? Into that radical, and 0 is the radicand. The square root of 0 is 0. So my first ordered pair would be 0, 0. And it's going to be an end point because there's nothing to the left of 0 that I can put in to my function. So the domain starts at 0, and then it's going to go all the way to the right in the positive direction because any positive number can be put in for x. So the next number I'm going to put in is a 1, and the square root of 1 is 1. So my ordered pair is 1, 1. And then if I were to put in a 2, the square root of 2 is about 1.4-ish. So if I use, I'd have to use a calculator to know that. 1.4 times 1.4 would get me close to 2. Well, that's not a number I know, and that's not a lattice point. So I'm going to try maybe 3. So we're going to go to the next number that we can put into our radical, into that square root function, that we can get a number out without having to use a calculator. So if I put a 3 in, the square root of 3 is not perfect. So I'm thinking of those perfect squares. These are not perfect squares, so I'm not going to even waste the space for 3. 4 is a perfect square. So the square root of 4 is 2. So when I put a 4 in, I get a 2 out. So I'm going to come over here and I'm going to plot that point, 4, 2. And then the next number that I can put in, is a 9. The square root of 9 is 3. I could put in other numbers. It's just that I don't want to have to pick up a calculator. 5, 6, 7, 8, 9. So 9, 3. And you get the idea. It's going to be a nice little curve, and it's going to go, let's make it a little bit better. There. And it's going to curve over to the right forever. The further to the right, the more up it's going to go. And that's our square root function. Now, we can now find function values of different square roots. So I've got in the first example, f of x equals the square root of 3x minus 2. If I want to find f of 1, everywhere I see an x, I'm going to put a 1 in its place. So I've got the square root of 3 times 1 minus 2. And the square root of 3 times 1 minus 2 is the same thing as 3 minus 2 in the radican. And the 3 minus 2 is 1, and the square root of 1 is 1. So f of 1 is equal to 1. Let's try another. G of z equals the square root of 6z plus 4. We want to find g of 3. So we're going to put a 3 everywhere we see a z. So instead of 6 times z, we'll have 6 times 3 plus 4. And 6 times 3 is 18. So we have 18 plus 4. And 18 plus 4 is 22. And 22 is not a perfect square, so I'm going to leave it just like that. G of 3 equals the square root of 22. If I were to use my calculator and find the square root of 22, I'm going to say it's about 4.8-ish, but you might be able to hear me taking out my calculator and looking at it, and it is 4.7-ish. So it is approximately, I'm going to put approximate right there, approximately 4.7. So G of 3 is equal to the square root of 22. That's the exact value. That's exact. And 4.7 is approximate. And then we have our last example. If you want to press pause and try any of these on your own, you're more than welcome to do that. H of negative 3 is equal to the square root of 1 minus negative 3. And 1 minus a negative 3 is 1 plus 3. And 1 plus 3 is 4, so we've got the square root of 4. So 8, which is 2. So H of negative 3 is equal to 2.